Okay, practical 2. Take down the heading as determination of mass of a body. Determination of mass of a body using principle of force moments. Body using principle of force moments. Force moments. Using principle of force moments. Right. Okay, first let's see the theory part involves here. Theory. Okay, listen. What is force moment as an equation? How are points A and B marked on the board? On the parallelogram? According to the scale. According to the scale. How? T1 is known. Ne? Since T1 is known, now let's say you have measured T1 using triple beam balance as 8 newtons. Right? If there is 8 newtons, according to the scale I have chosen, I have to draw a line of 8 centimeters long. Right? Then that end point is point A. So do we want to copy parallelogram A dash? Yeah, we copy it down. Yeah, you copy it down. Okay, listen. As an equation, first tell me what is a force moment? What is force moment as an equation? What is force moment as an equation? Basics. Force moment. Usually we say G. What is force moment as an equation? Huh? Quickly. So did you say to copy the practical setup? I guess I didn't get your question. You are asking whether the first one about the first diagram. What is a force moment? Force moment is a force into perpendicular distance. Is defined as a force moment. Force moment is a force times perpendicular distance as an equation. Force times perpendicular distance. Right? So therefore, force moment is defined as F times D. Force moment. Right? What is principle of force moments? For a system in equilibrium. For a system in equilibrium. What is the principle of force moments? Now, with the previous example or previous experiment also, I had to explain. There are two conditions satisfied by a system in equilibrium. One is algebraic summation of forces along any direction is 0. And the other one is algebraic summation of force moments around any point is 0. Right? So therefore, if a system is in equilibrium, see, look at here. Look at here. Let's say these two weights are kept on this as let's say its weight is m1g and this weight is m2g, and this is a pivot point. Let's say g, and say this is d1 and this is d2, right? If the system is in equilibrium, look at here. This is the theory here. If the system is in equilibrium, force moment in counterclockwise direction about g equals clockwise force moment about g, right? Counterclockwise force moment is due to m1g, force into perpendicular distance, so m1g times d1 equals clockwise force moment is due to m2g, right? m2g into perpendicular distance, then m2g times d2, right? So this is the principle. This is the principle. So therefore, if a system is in equilibrium, force moments are equal. Force moments are equal. That is why algebraic summation becomes 0. Algebraic summation means plus minus addition. Right? So therefore, force moments are equal. Right? Okay, this is the theory involved here. Take it down. This is the theory part involved here. Take it down. What's the full form of M1G? You're asking the meaning. I considered weight of fan as M1G. I mentioned it here somewhere. Weight of fan. Finished? Finished? Okay. Next thing. Okay, look at the board. First thing, we have to have a meter ruler and a knife edge for the experiment. I know you know meter rulers. What's a knife edge? Knife edge is there no? Knife edge means that is not actually a knife edge. Again, a knife edge. Knife edge means a very thin edge like this that we can keep something on it. This is called knife edge. Right? It's like a needle. A needle like knife edge. That is called knife edge. Right? The reason to say that as a knife edge is because that's very thin. Knife edge edge tip thin. Right? Hey, make a stand මේක ලැබ් එකේ තියෙනවා මේක ස්ටෑන්ඩ් එක තියෙන්නේ මෙහෙම තියෙනවා knife edge එක on stand. This is a knife edge. Right? We have to have a knife edge first and a meter ruler. Right? And a meter ruler. Okay, look at the board. Look at the board. First thing is we have to take the meter ruler and we have to keep this meter ruler in equilibrium on the knife edge like this. You have to keep the meter ruler in equilibrium on the knife edge like this. Right? Now, even though it's a symmetric meter ruler, its center of gravity is always not going to be at 50 centimeters. Right? There can be differences that we don't know, so we can't rely on that. Right? So therefore, we are taking the meter ruler and if we can balance it on the knife edge, the point where it balances exactly should be what? Should be the center of gravity. Now, otherwise, if there is not the center of gravity, it collapses. Right? If there is at the center of gravity, right, it balances. Are there any sticks somewhere? මොනවා restricts තියෙනවද වෙන? දන්නවනේ ඒක කරන්න පුළුවන් කියලා දන්නවනේ. පොඩි කාලේ කොස්සෙම balance කරලා තියෙනවා. හරි ඒක දන්නවද? Is there anything that I can show you? No. So you can imagine, no? So likewise, on the knife edge, this meter ruler should be balanced. Right? On the knife edge, this should be balanced. Now, at that balance point, make a balance around. At that balance point, it is balancing means center of gravity is at the same point. Otherwise, if that is not at the same point, there will be a non-zero force moment. With that force moment, it collapses. Right? If it is balanced, which means center of gravity is there. Right? Now, doing this, first thing is you have to find the center of gravity of meter ruler. You have to find the center of gravity of meter ruler. Right. Now, from center of gravity, what is center of gravity, by the way? What is center of gravity? So, how will it be balanced in the knife edge? This is not a rocket science. Just keep it on the knife edge and change the position accordingly until it balances. Haven't you balanced booms like sticks in your childhood? මන්නම් කළා දෙනවා. මේ ස්ටික් එකක් තිබ්බනම් පෙන්වන්න තිබ්බ මට ස්ටික් එකක් නැහැ පෙන්න. Yeah, that's it. Over there. Can I throw it? Was it a pen? I thought it's a pencil. Oh, okay. Now assume this as the meter ruler. Assume this as a meter ruler. Then keep it on the knife edge. Once it is kept on the knife edge, if there is not balance, which means your center of gravity is not at the point of the knife edge. Like this, it falls. Once you take hands off, it falls. But if it balanced, see, it can be kept balanced like this. You have to find this position. Now, which means center of gravity of this pen is here. Right? Center of gravity of this pen is here. Right? Make it rotate pen now. Make a pen kinda. Center of gravity is here. That's the same idea. Center of gravity of the meter ruler is now at that same point. Is it broken? Won't it fall then? But the knife edge is very sharp, then will it fall? No, it won't fall. Now that's the beauty of physics. It won't fall. When you take that knife edge exactly to this point, because center of gravity is a point. It's a point. Right? Make a balance කරන්න පුළුවන් එක needle එකකින්. Right? පස්සේ කරලා බලන්න එක needle එකෙන් balance කරන්න පුළුවන්. Right? හරියටම මේ point එකට එනවා. Got it? Okay. So what I asked about is what center of gravity? What is center of gravity? We have discussed in the theory class like how many months back? 5? 5 or 6 maybe. More than 6, I guess. Yeah. What is center of gravity? The point where weight, yeah, good. The point where weight of an object acts. Right? Acting point of weight. Center of gravity is acting point of weight. So which means weight of this meter ruler acts here. Right? That's why it is in balance. Right? Otherwise, if there is not in balance, what happened is, let's say center of gravity somewhere here. Now this creates mg. This creates a force moment of mgd, and this falls in this direction. Right? When this point is taken to here, since there is no perpendicular distance between that point and the knife edge, no force moment, zero force moment, which means it won't fall. Right? That's the thing. Okay, listen now. Listen. Okay, now this is balanced. And then we have to have two weights. I'm measuring materials to clear. Now we list down. Now we have a meter ruler. What else? A knife edge. Other than that, we have to have two weights. One is a known weight and the other one is an unknown weight. Determination of a mass. To determine, we have to have an unknown one. Otherwise, if it's known, there is no point of determining. No? So therefore, one known weight or one known mass and one unknown mass. one known mass and one unknown mass, right? Okay, look at here. Now, using thin strings, we have to, listen, we have to hang the weights here on the meter ruler. You have to hang these weights on the meter ruler, right? Let's say my known weight is capital M. My known weight is capital M. So here that it has a weight of mg, right? And now as this equilibrium is not broken, you have to fold the other weight, the unknown weight, on the other side like this. So this is my unknown weight, simple m, simple mg, right? And the purpose of using a meter ruler is to take readings easily. Now in meter ruler we can see the scale. We can see the scale. Now this is not exactly at 50 usually. It will be around 50, right? Make a 75 volt වගේ එන්නේ නැහැ. එහෙම නැත්නම් මේක එහෙම meter rulers නෑනේ. Meter ruler is just uniform, but we don't know whether it's exactly uniform. Make exact 50 volt එන්නේ නැහැ. It may be like 51 sometimes, 49 sometimes, somewhere around, right? But somehow we know the scale and the point there on the meter ruler. Let's say that is 51.1, then we know that as 51.1 centimeters. So therefore, these lengths can be read out at once using the meter ruler itself, right? So let's assume this distance from here to here as x, this distance from here to here as y, right? Now if this is balanced, the idea again is this: if the system is in equilibrium, if it is balanced, these two force moments should be equal, and there is no force moment comes from mg of meter ruler, since I have balanced it to the knife edge. We are going to write the force moments about knife edge, right? No perpendicular distance to the weight of meter ruler, since there is acting through the knife edge, right? Therefore, now if I consider equilibrium, see, look at the board, don't write. By considering equilibrium, force moments about G in both directions should be equal. Counterclockwise force moment equals clockwise force moment. Counterclockwise force moment is due to this one, capital Mg times x, and clockwise force moment is due to simple mg times y. Right, now you can see G to G cancels, right? What comes is mx equals my, capital Mx equals simple my, right? Okay, now from here we can read two readings for x and y. No, you can read out from the scale. You know, whether 51 scale, x is 51, let's say this is at 20, this 20 is 31, something like that. We can directly read it out, right? We can read these readings. So likewise, what we are doing is this: we are, look at the board, we can do the same for around 6 readings. Now there's a practice like we need minimum 6 readings to draw a graph. Simply graph එක අඳින්න නම් අපිට minimum 6 readings තියෙන්න ඕනේ. That's a practice. That's the practice we practice in A levels, right? Minimum 6 or more than that. දෙකක් විතර තියාගෙන graph එකක් අඳින්න නැහැ, because the accuracy is very low. So therefore minimum, when we take readings in something, we are taking 6 readings. Keep that in mind. To plot a graph, if you are taking readings, minimum number of readings you have to take is 6. Minimum is 6, right? Now likewise, now we are going to change x. Listen, we are going to change x. Distance of the known weight is going to be changed. We are going to change x. We have hung this from this point, so we are taking this to this side a little bit. Then accordingly, this should also be moved away to counterbalance again. So likewise, we have to do it 6 times for 6 instances, right? And then you can get 6 pairs of x and y onto a table. 6 pairs of x and y onto a table, right? And now we were changing x. In a graph, changing variable is called the which variable? There are 2 variables for a graph. What are them? What are them? X and y. What are the names? What are the names of variables x and y? No. Independent variables and dependent variables. Independent and dependent. X is called independent. Y is called dependent variable because y depends on x. Right? So independent variable means a changing variable. Independent means that doesn't depend on anyone. But y is depending on x. Y is called dependent variable. Now we are changing x now. Changing variable is the independent variable. Now independent variable will be x, and with respect to x, y changes accordingly. So therefore y becomes the dependent variable. That's why I use x and y for you to see it properly. Right? නැත්නම් මේකට L1 L2 හරි මොකක් හරි දාන්න තිබ්බා ඒතර. කරලා යනවනේ. Right? X is the changing variable, independent variable. Now, since we need to plot a graph, we can make this equation to plot a graph. See, now my dependent variable is going to be y, subject y from this. See, y is given by capital M over simple M x. Y is given by capital M over simple M x. Right? Now, if we plot a graph using this, now my y axis is as same y, x axis is same x, and this part will be the gradient. Anything which is as a product with x is a gradient. Right? You can see, right? So we will get a graph of the shape y equals mx. We will get a graph of a shape y equals mx. Right? So after taking these 6 readings, what we do is you are plotting this graph. You are plotting this graph. Right? On a graph sheet, on a graphing sheet, we are plotting this graph y and x. Right? Then you can mark these points. Now you have 6 points. You are marking these points and plotting the graph. Always, not all 6 points are going to come onto the same straight line. That happens when we do experiments. Right? So majority ගන්න අපි graph එක ගහනවා. And gradient of this graph is gradient of this graph is gradient. Let's say k, gradient k කියලා දාන්න. Usually we use simple m for gradients. Since we have a simple m already here, I'll be using k for this gradient. This gradient is capital M over simple m. That is what is coming from here. This gradient is capital M over simple m. Right? Okay. Let's see what we are going to do with the gradient now. Now we have finished the note here. Materials with there. Good. Okay, as the next heading, write down materials and apparatus. Next heading, materials and apparatus. Next heading, don't write anything here. Don't write anything here. Write the heading, materials and apparatus. Materials and apparatus. Right? Okay. First write down materials. First materials. Under that, first thing, materials. First thing, material. Right. Write down one by one. Meter ruler. A meter ruler. A meter ruler. A meter ruler. Second one, a knife edge. Next one known weight. One known mass. 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 Within brackets. 50 grams. Within brackets 50 grams. Next one unknown mass. One unknown mass. One unknown mass within brackets a small stone. A small stone. unknown mass එකකට ගන්න මොකුත් නැත්නම් අපි හැම වෙලාවෙම lab එකේදී ගන්න එක්ක ගල් කැටයක් එහෙම නැත්නම් අර glass top එකක්. right? ඒක තමයි small stone or glass top එක use කරන්නත් පුළුවන්. right? Next one, a piece of string. A piece of string. මේ දෙක එල්ලන්න strings ඕනේ. A piece of string. A piece of string. Last one, a wooden block. A wooden block. A wooden block. A wooden block. Okay, look at here. If this height is not enough, you can use a wooden block here and take it to a required height. That's why a wooden block is the wooden block. Wooden block. Right. Okay, next heading, apparatus. Next heading, apparatus. Next heading, apparatus. So it's a ruler you have drawn. So it's a ruler you have drawn above the knife. Yeah. This is a meter ruler. This is the meter ruler. This is the meter ruler. Dependent, that's good. So can't it be mx of m instead of asking gradient? Gradient is always the part which is as a product with x. Now let's say you have an equation like say y equals 2x plus 5. Y equals 2x plus 5. 2 is the gradient. Right? 2 is the gradient. The multiplier, the coefficient of x, coefficient of independent variable is called the gradient. Because gradient is y of x. Gradient is tan theta over y of x. That is how gradient is defined. And now for the experiments coming up, graphing knowledge is needed because for all other experiments we are going to use graphs and get something done using the graphs. If you don't know about graph plotting, I have conducted a class like 5-6 months back about graph plotting for A-level physics. Right? That video is still available on my YouTube channel. So you can just go there. I think it's around 3 hours long, maybe 2.5 hours, 3 hour long video. Right? You can go there and check everything out. There are 16 different types of standard curves we have. Right? All 16 curves we have to know. And about gradients, gradient types, graph plotting, and it was ended with the discussion of 20 or 25 graphing questions. I think 20, right? 20 graphing questions. That tut is also you can get. Now I think I have pinned that in the, not pinned, I have mentioned that in the description of the video. Just go to the description of the video and click on a link. I guess the link is there. Go to the link and you can download that tut as well. I gave a small tut for that thing. So please watch it in a leisure time as early as possible, because now you are in a high time to know about graph plotting for all experiments. Most of the experiments, graphing is coming, and other than that, when it comes to 50 MCQs, there are 10 graphs. There are 10 graphs in 50 MCQs, right? And in structured essays, you are getting graphs. Essays also you are getting graphs. Around 15% of marks out of 100, final 100 marks, around 15% is allocated only for graphs in A-level physics, right? So therefore, knowing graphing is a must, right? Right. So if you are not familiar about these terms, graphing, gradients, independent variables, dependent variables, intercepts, y-intercepts, x-intercepts, and standard curves, right? In a leisure time, please go there and watch it. It says graph plotting for GC A-level physics. එම කියලා වීඩියෝ එකක් ඇති යන්නේ වීඩියෝ එක බලන්න. What should we need to do under the heading apparatus? Wait, I didn't say anything. I'm just looking at the questions. So sir, if I keep a ruler on the edge of a knife from from kitchen, then ruler will be balanced from kitchen. Okay. From kitchen now again. Actual knife edge. Yeah, it will be balanced. Listen. Listen. It will be balanced. It will be balanced. Now, if you do so, listen, if you do so, now, you know, if this is a meter ruler, there are two symmetric axes going like this. So the exact point is coming to the center point, middle point like this. So first find that center of the meter ruler and keep your knife at that center point. Then it will be balanced, right? Otherwise, now in this knife edge that is in the lab, there's a small modification done to make it easier. The knife edge, the knife edge is like this. It's having a small width. Even though it's thin, in these knife edges we have in labs, it has a small thickness like this. So meter ruler එකක් වගේ තිබ්බට පස්සේ meter ruler එක මේ ගානට මේකට හිටිනවා. ෆෝන් එක වැටුනොත් මෙන්න මෙහෙම meter ruler එක ගානට තියන්න පුළුවන්. In that case. ඒක dot එකක් නෙමෙයි, කියන්නේ ඒක needle එකක් වගේ dot එකක් නෙමෙයි. It's very sharp. But like this it has some kind of a thickness. පොඩි thickness එකක් තියෙනවා. උතර ගානට thickness side එකට මෙහෙම ගිහිල්ලා තියන්න පුළුවන්. ඒක ලේසි. නැත්තම් මෙහෙම දැන් මේ edge එක උඩ තිබ්බම දෙපැත්තටම මේක imbalance වෙනවනේ. මේක වගේ උඩ තිබ්බට පස්සේ ඔයාලට මේ direction එක විතරයි බලන්න තියෙන්නේ. right? මේක උඩ balance කරන්න පුළුවන් ඉතින් මොකක් හරි තිබ්බනම්. And this should be firm on the table, because naturally we have our own vibrations. Human hands මේ body එකම natural vibration එකක් තියෙනවා. ඒතර මේක මෙහෙම firm තියෙන්න ඕනේ. ඉතින් මට තියාගන්න බැරි වෙයි. මේක firm තියෙනවා. මේක solid මේ තියෙන මේ table එකක් උඩ. This is on the table. So that is firm. That is fixed. Right? So ඒක උඩ ඔයා මෙහෙම ගිහලා මේක තිබ්බනම් ඒක ගන්න balance වෙනවා. Right? මේක හොල්ලන්න නැතුව තියාගෙන පුළුවන් කෙනෙක් ඉන්නවා නම් මම තියලා වෙන්නම්. මෙන්න මෙහෙම තමයි එන්නේ. මේ ටේබල් එක උඩින් තිබ්බොත් මම පෙන්නන්නම්. අත අපේ natural vibration නැත කරන්න බෑ. Naturally we have a vibration in our hands. Right? එහෙම තියන්න පුළුවන්. මේකට පොඩි thickness එකක් තියෙනවා. Then that would be easy. Don't write anything. I'm just answering your questions. So why are we taking an unknown mass for experiments? That is the experiment. See the topic? Now we are going to determine this using force moments. The experiment එක කළා මොකක් හරි හොයාගන්න එකක් තියෙන්න බෑ. Because experiments are done to get something out. Or to conclude something, to get something out. Right? Experiment එකක් කළා මොකක් හරි දෙයක් outcome එකක් තියෙනවා. Now the outcome here is we are going to determine this mass. So how many marks for MCQ paper? 50. 50. So will this recording be uploaded to YouTube? I missed the first few hours. Yeah, it will be there for today for sure, right? Yeah, it will be on YouTube for today for sure. And yeah, I'll think whether it's to be kept on YouTube or gonna remove. Let's see with your behavior. Right? If your behavior is good, I can keep it on the YouTube. Yeah, for sure for today it will be there. Right? For today and tomorrow, let's say, it will be there. So what if it's given that the mass of unknown mass is approximately 60 grams and asked to choose the appropriate known weights out 50? That I didn't explain yet. Now, when you choose these masses, these two should be approximately equal. Otherwise, you won't get balance points. Right? Now, if you are using 50 grams, I told you the known mass is 50 grams. Usually, we are taking a 50 gram mass. If there is 50, now if you are using like 1 kilo something on the other side, it won't be balanced. 1 kilo right? So it should be approximately equal. Now for your question, the answer is 60. Whole paper marks 100. So can we buy a graph book for physics? You have to. You have to. Now, if you are not a private candidate, you are going to school name. There is one slot per week allocated for practical sessions. So weekly, there's one session. One session of 2 periods. 2. Oh. Right? So weekly, 1 hour and 40 minutes are allocated for practicals. Then you will be spending that time, that whole time in the lab. That is how these 42 practicals are going to be covered in the school weekly. That is how it's covered in weekly basis. Right? It will be covered weekly. Right? That's the idea. For that, you have to have a graphing book. Right? Now, usually, for the practical period, experiments period, you have to have a graphing book. Right? That's all. Okay, right. So what do you write? Apparatus. Okay. First, write this down. Look at here. Look at here. First, take this down. Just the meter ruler on knife edge. Just the meter ruler on knife edge. Take this down. Take this down. Just the meter ruler on knife edge is balanced. Take this down. Only the diagram at left side. The structured essay marks are divided. Our second paper marks will be divided by 4. So one structured essay it carries 20 marks. So which means out of 100 there is 5 marks. Right? One structured essay is for 20 marks. So making structured essay ka aapko 20 marks. Out of 100 there is 5 marks. Right? You have 4 structured essays, which means 80 altogether. When taken down to 100, that is 20. Right? Structured essays are 20%. That's a huge amount. 20% out of 100. 1/5. 20%, that's a huge amount. Right? 20% කියන්නේ 20 marks. 100 එකක් කෙලින් මේ එකක් වෙන මාක් එකක් නේ. 55 එක 75 එක ගන්න නේ. Very critical, very critical. We'll be getting 4 experiments from all 39 available. Right? 4 out of 39. It's for 20 marks out of 100, final 100. That's all. Okay. Write down below. Write down below. Keep the meter ruler. Keep the meter ruler in equilibrium. Keep the meter ruler in equilibrium. Keep the meter ruler in equilibrium on a knife edge. Keep the meter ruler in equilibrium on a knife edge. Keep the meter ruler in equilibrium keep the meter ruler in equilibrium on a knife edge and find its center of gravity. And find its center of gravity. And find center of gravity. And second point, hang the known mass and unknown mass. Hang the known mass and unknown mass hang the known mass and unknown mass in either sides of meter ruler using strings. In either sides of meter ruler using strings. In either sides of meter ruler using strings. Right? Take this down. Only the diagram. Only the diagram. Don't write this thing. This thing comes under method. Now we are studying the apparatus. Take down this diagram. Only the diagram. Only the diagram. Up to here. Up to here. Take down only the diagram. Nothing here. Not the table. Not the graph. No. Just the diagram. Take it down quickly. So if you have any questions, you can put them to the chat, right? I can see all your chat now. When I check your chat, I can see all your messages. That's why I'm answering all of them at once, right? Otherwise, it's not practical to check them one by one, right? So I'll discuss this with the flow, and then once I check the chat boxes, I can answer all your questions at once. Finished. Use different colors if needed. That's up to you. That's up to you. Right? Okay. Then next heading, method. Method. Next heading, method. Next heading, method. Method. Record 6 readings. Record 6 readings. What? Which door? Second floor. Yeah. Don't close kill again. Hurry. Hurry. What did I say? Record 6 readings for X and Y. Record 6 readings for X and Y by changing. Record 6 readings for X and Y. Record 6 readings for X and Y. Record 6 readings for X and Y by changing the distance from, by changing the distance from balanced point to known mass. By changing distance from balanced point to known mass. By changing distance from balanced point to known mass. By changing distance from balanced point to known mass. Within brackets X. Within brackets X. Okay, then write this down. By considering equilibrium, and write down up to here. Up to here. By considering equilibrium. By considering equilibrium, write this down. And now we have got this equation y equals mx. y equals mx. Now that is in the shape of y equals mx. That is in the shape of y equals mx. So is the previous 2 points you gave should be write in red? No. Finished. Okay, now take this down, this table. Here we have 6 pairs of values. 6 pairs of values. Right? This is called data table. Data table. Data table. Right? Okay. Then we are going to plot the graph. Look at here. According to above equation, get here. According to above equation, now you know final equation is y equals capital M over simple m times x. Right? So this is in the form of y equals mx. This is a standard curve. Y equals mx is a standard curve. This is in the form of y equals mx. Right? So standard y equals mx curve is this. Standard y equals mx curve is this. Right. Standard y equals mx curve is this. Right. Now, using this, you know, gradient, let's say k equals capital M over simple m. Right. Since k equals capital M over simple m, see k equals capital M over simple m. The unknown weight is this one. This one is the unknown one. Right? Known is capital M, unknown is simple m. Right? Then simple m is given by capital M over gradient. Simple m is given by capital M over gradient. If gradient is known, capital M is a known weight anyway, known. This is known. If gradient is known, simple m can be determined. Right? Now, once the graph is plot, what we do is you can select any 2 points and get the gradient of this graph using delta y or delta x, which means gradient is known because k equals, I'll mention here. Now k from the graph, k is a gradient. Gradient equals y over x or delta y over delta x, change of y over change of x, delta y over delta x, which means is known. If that is known, plug that value here, simplify, we can find simple m. Simple as that. It was determination of mass. Right? So mass is determined. Right? Now, just by taking one pair of readings also, we can find simple m. Right? Listen. Just by using one pair of x and y also, we can find simple m. May first equation with x and y done can find, but we don't do it. The reason is accuracy is very low. When we have multiple readings, 6 readings, accuracy is good. So that's why we are going to a graphing method. Always in graphing methods, accuracy is higher. Gradient taking everything. නැත්නම් එකපාරටම equation එකට දාලා ගන්න පුළුවන්. තමයි accuracy එක නෑ. එහෙනම් එහෙම කරන්නේ නෑ. Right? එහෙම කරන්නේ නෑ. We don't do it. Right? Because now this is A-level physics. You have to do experiments with an accuracy. නිකම් මේ toys එක සෙල්ලම් කරනවා වගේ නෙමෙයි මේක. ඇත්ත දෙයක් නෙමෙයි කරන්නේ. Right? So that's why we are going to the graphing method. නැත්තම් මේ equation එකට මෙතනට ආව ගමන් x and y and capital M ආනෝනේ. If you simplify the equation, you will get simple M. But that is not that accurate. That's the reason. Always we are going to the graphing method. Right? Okay. Now start from here and write up to this point. Start from here and write up to here. Yeah, that's it for this second experiment as well. There are a few important facts to be mentioned. As the previous one, I'll mention few facts as remarks and important points. Right? Other than that, now the method is this. That's done. That's it. Any questions? So what's that last formula? Y equals mx. Y equals mx. This one here. Y equals mx. This is a standard curve. Y equals mx is a standard curve. දන්නවනේ you have මේ වගේ ඒවා තියෙනවනේ. Y equals ax squared plus bx plus c. Standard curves. Right? Y equals mx plus c. Standard curves. So they are standard curves. So there's no time to wait if you don't know graph plotting. Right? I'm serious. Now from my side, the only option that I can give you is that video of the recorded video of the class is on YouTube, so you can watch it later. Right? Allocate some time and watch that video and practice those questions. There are 20 questions we practiced after the session. Right? That is also in that session, that's in the video, so you can watch it and make yourself comfortable with graph plotting, because that's a must needed skill. Otherwise, without knowing graph plotting, don't go to the exam. Right? 15 marks or graph plotting දන්නේ නැතුව exam එකට යනවා කියන්නේ 100 වලින් නෙමෙයි වට marks එන්නේ 85 වලින්. Right? 15 will be for graphs. So do you want to copy the data table after graph or copy? I told you to copy it down. I asked you to copy it down. Data table copy කරන්න කිව්වේ නේද? I asked you. නේද? I asked you to copy down the data table after this point. Didn't I? No? Huh? Yeah, I said. I said. I asked you to copy down the data table after this. Without the graph. Graph එක නැතුව data table copy කරන්න. If you didn't copy it somewhere around. Right? That is when I label this as data table. Right? Copy it down somewhere around. That's fine. That's fine. එහෙම critical එකක් නෙමෙයි ඉතින්. ඒක copy කරලා තියාගන්න. If you have put direct messages to my personal account, please forward them to the Matchma account, because I'm watching at the chat there. That's why. YouTube chat is on my other laptop. That's why. Right? Finish? Okay. Last heading. Remarks / important points. Remarks / important points. Remarks / important points. Remarks / important points. Okay. Write down in point form as bullets as we did before. Right? First point. Weight of meter ruler. Weight of meter ruler has no impact on force moments, has no impact on force moments, weight of meter ruler has no impact, has no impact on force moments, has no impact on force moments, since its pivot point is at, since its pivot point is at center of gravity, since its pivot point is at center of gravity, since its pivot point is at center of gravity, since its pivot point is at center of gravity, pivot point is at center of gravity. Next one. Using two approximate weights, using two approximately equal 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 weights, gives a good spread, gives a good spread, gives a good spread, gives a good spread for readings of x and y, for readings of x and y. Good spread, good spread කියලා කියන්නේ listen, good spread කියලා කියන්නේ match වෙන්නේ නැති values ගත්තොත් එහෙම මේ graph sheet එකේ වාගේ graph එක පොඩ්ඩියට එන්නේ නිකන් මෙහෙම එනවා. වැඩක් නැහැ spread යන්නේ. Right, then in such cases percentage errors are high because always higher lower reading percentage errors are higher. Percentage error done, percentage error is least count over reading, right? Always lesser the reading, higher the percentage error. So therefore we have to have a good spread. මුළු sheet එකම use කරලා ඉතින් මේක ලස්සනට අදින්න ඕන. right, එහෙම වෙන්න හොඳ spread එකක් තියෙන්න ඕන. okay, what did I say? Equal to masses gives a good spread for the graph. Is it? Readings of x and y. What did I say? Using two approximately equal weights gives a good spread for readings of x and y when plotting the graph. When plotting the graph. When plotting the graph. Next point. Accuracy of the method is higher since it's a graphing method. Next point. Accuracy of the method of this method. Accuracy of this method is higher since it's a graphing method. Accuracy of this method is higher since it's a graphing method. That's what I mentioned before. Now, even though we have an equation here, we don't go for the equation. That is less accurate. Right? Always we have to go with the graph. පොඩි කාලේ වගේ ඩොග් ගාලා equation එකට දාලා ගන්න නෑ උදේ. එහෙම තමයි ඇටි. Now you are A-level physics students, no? Physics. Right? නැත්නම් නිකම් මේ equation එකට substitute කරලා එහෙම ගන්න නෑ. Got it? Got it? Okay. Right. That's all. That's all. So that's the end of practical 2. Right? That's the end of practical 2. So before giving the break, now I'm planning to finish first 3. Otherwise we will be running out of time. Okay, now it's 11:39. We have around 1 hour. All right. Any questions before moving on to the third one? Any questions before moving on to the third one? So I had written in red, is it mass? What is capital M? What is capital M? Non-mass. Non-mass. Someone had answered, ne? Good, very good. No, it's known. Capital M is known mass, simple M is unknown mass. Ne, it's see there. Ne? Known mass is capital M. Unknown mass is simple M. Last point. Accuracy of this method is higher since it's a graphing method. Accuracy of this method is higher since it's a graphing method. Okay, that's it. Any other questions before moving on? Before erasing? What about you? All clear? The ones on YouTube? What about you? Now, when I ask something that's for both of you, doesn't matter if you are on Zoom or YouTube, right? If you are online, you can put your things, put your doubts, questions, anything to chat box. Or is it clear? So at least put the thumbs up if that is clear enough. Otherwise, I'm going to erase this. We are going to move on to the next practical. All right, good. Okay then. Okay, right. Okay, what about the first two practicals so far? Now we started this session around 8:45 or something, 8:45 or something, and now it's 11:42. 11:42. Yeah. What about the two experiments we discussed? I mean, how do you feel? I couldn't hear. So what is capital M in gradient? Capital M is known mass. Wherever it is, that is known mass. What did you say? Clear? Right. So you have spent your holiday effectively and productively so far, right? No, otherwise, if you don't have school, what do you usually do? You don't have any. If you don't have school, what do you do usually? Sleeping until 10, 11, is it? Online students? Online means you are anyway the lazy ones. That's why you are joining online. I mean, if you are around Colombo, if you are from a remote city, that is fine. That is totally fine. But I can see there are some students who live around Colombo also in the online class. That is because of the laziness you have, right? That's the laziness. Yeah, tell me. Yeah, you are sleeping, ne? If you don't have school on a regular day, usually what you are doing is you are sleeping, right? Give me a minute. No, will be around 2 or 2:30. Dude. Right. I think you have a space to sit there. All right. Also, that's also effective. We are saving the time for transportation, taking transportation. Very good. I said if you are around Colombo in the sense if it's like, let's say 30 minutes, 45 minutes, that will be just that's not a waste. That's not a waste. That's just a productive time you are spending, right? And I know there are some students who live like very close by, like 30 minutes away. Now in the online meeting, that's why I told you. So what is capital M in gradient in red color you wrote? Known. මේක දැහුවේ එච්චරලා. Known. And gradient is also known from here, which means M can be determined. Now if needed, put a point somewhere here. Since capital M and K are known values, simple M can be determined. Right? ඕන්න මෙතන point එකක් දාගන්න. Since capital M and K are known values, somewhere here, since capital M and K are known values, simple M can be determined. Since capital M and K are known values, simple M can be determined. But we are better than physical because they are sacrificing time, but we are sacrificing ice. Yeah. Now, yeah, that's totally up to you. Again, up to you. There are some students who are not familiar with the online things, but there are some of you, they are very much familiar with the online setup. So that's why nowadays in the modern setup, we have to go with both. Right now, actually before COVID, we didn't have any online thing. Right? Everything was physical. But now after the COVID, now even though that's a disaster came, there are some positive sides from that as well. So one of the things is this, right? Now otherwise, now the access to these kind of classes for any student is, it was not there. And if there was no, I mean, if there was nothing happened like COVID, I don't think we will do this conversion, this evolution this much faster. Now, for COVID, we have to stay around like 1 to 2 years, I guess, 1 to 1.5 years or something, as working from home, inside home. And in those days, we had to shift by, I mean, by whether you like it or not, right? By hook or hook, we had to shift to it, right? For companies also, all the meetings were taken online, all classes were taken online, and we got used to that culture, right? So that's one of the good things actually, right? So what I'm saying is online learning is a good thing. Online learning is a good thing, right? Any student anywhere in the world can access any class, right? That's the beauty. That's a good thing. That's a good thing, right? I clearly said, I said for the students who are around, right? Candy නම් වා candy නම් මෙහෙන්න එපා ඔබ. candy නම් මෙහෙන්න එපා. And it may be I'm the one who is coming from the furthest point to the class. It takes around 2 hours for me to come, right? So my today's schedule is, yesterday it was around 1:30, 1:45 in the morning. In the morning means in the dawn when I'm going to sleep. So I had to finalize several things about this today's seminar, and then had to wake up at 5, right? And then I got ready and came. It usually takes around 2 hours to come here from Corona. right? And I was here by 7:30 anyway. One thing is, I forgot that today is a mercantile holiday, so there was no traffic. Then I came faster. Otherwise, the areas like Vellavatta, this corridor is having heavy traffic in these office hours now. So I actually forgot that that's a mercantile holiday. I knew that that's a public holiday, but I didn't know that it's a mercantile. Then I checked, since I noticed that there's less traffic on roads, I check whether it's mercantile. Then only I noticed that it's mercantile. So therefore there was no traffic. So today I came, yeah, in around like 1.5 hours. So I was here by 7:30. Can anyone send a pic of the note? Oh yeah, you have got it. Okay, right, good. Let's move on. Practical three. Practical three. Practical three. Take down the heading as determination of